In this video, we will discuss measures of central tendency. So first, let's review a little bit about summation notation. Many formulas in statistics will involve adding up many items. Particularly, it will say add up all the items in this list. Whenever we have repeated addition of items in a particular list or something that we can describe mathematically, we can use something called summation notation. In summation notation, we use this symbol, which is a capital Greek letter sigma, and it tells you to add up all the things that look like x. So what you can see here on the right side of this equation is we are adding up all the values x sub 1 plus x sub 2 plus next would come x sub 3 all the way up to x sub n. So here the subscripts, the things written in the bottom right corner of the letters, are indicating the order of the data item in the list. So for example, if I labeled all my data items that you now see on the screen as x, then the sum of all data values x would be the first data value 1 plus the second data value 1 plus the third data value, which is a 2, plus the fourth data value, which is a 3, and then continuing to add up all the data values in the list. So we would add these all together, and that would be the sum of all the data values. So the sum of all of these data values is the number 22. So that's a bit about summation notation. With this in mind, let's review the definition of the mean. Now, probably a phrase that we're more familiar with in terms of mean is the average. In order to find the mean of a list of data values, so here my x sub 1 through x sub n are just a list of data values. In order to find the mean of those data values, if there's n data entries in all, we could calculate the mean by adding up all of the data entries and then dividing it by the number of entries. And that's exactly what we see here. We see the summation notation telling us to add up all the data entries together, which is what we see on the right side of the equal sign, and then divide that by n, which is the total number of data entries. Let's practice this concept. A city issued the following numbers of building permits over a 6-month period of time. One of the months, there was 310 permits issued. Another month, 296, 240, 374, 198, and 280. From these 6-month period of time, we're asked to find the mean number of building permits given out over that 6-month period of time. So how many data entries do we have? We have 1, 2, 3, 4, 5, 6. So n, the number of data entries is 6. In order to find the mean, we will add up all the data entries and then divide by the number there are. So we already know the number is 6. Let's add up all the entries together. So I'll take the 310, add that to the 296, add that to 240, add that to 374, add that to 198, and finally add that to 280. Now let's add these first values in our calculator, and then we'll write what that's equal to, and then finally we'll do the division. The sum of all the building permits over the 6-month period is 1,698. We'll now divide that by 6 to get our mean. And we find there are 283 building permits issued on average during the 6-month period of time. Another measure of central tendency is the median. Now, the median is useful to find because it is not so sensitive to what we might call extreme values or outliers. Instead, it will divide the group of observations into two parts, with half of all the data observations lying below the median and the other half lying above the median. So how do we find the median? First, we need to rank all the items and arrange them in order from least to greatest. So if you're given a data set and asked to find the median, do not assume that it's already written in order. You would have to check that first and then reorder it. Remember, if there's repeated data entries, you have to keep those repeated data entries and include that as you reorder the list. Step 2 is to find the number in the exact middle of the list. Now, if the total number of items in the list is odd, then there will be a unique middle item in the list. You can see what's exactly in the middle. However, if the number of items is even, there's not an exact middle entry. Instead, you have to take the average of the two middle items. So you'll find the two items in the middle, add them together, and divide by 2. Let's practice finding the median of a few different data lists. And a quick reminder is whenever we find the median, we must make sure the values are in order. If they're not in order, let's rewrite the list in order from least to greatest. Let's work on this first example. If you would quickly look through the list and identify, is it written in order? Because if not, we must first reorder it. Looking at the data entries, we see 6, 7, 9, 11, 15, 25, 33. Everything is numerically in order here. And one way we can work this out is, since it's numerically in order, I can find the middle item by slowly working myself towards the middle. I think about canceling the first and the last digit, canceling the next to first digit, the next to last, and we continue this way until we see that there's 3 items to the left of 11, 3 items to the right of 11. That makes 11 our median value. So the median is 11. Now, as we turn our attention to the next example, let's briefly look through and see, is the list in order? Because we know median must have an ordered list. Here we quickly see it's not in order, so I would encourage you to pause the video now and rewrite this list in the correct order. Unpause to check your work. So as we reorder it, I always like to mark once I've used a number so I don't forget. I'm not going to cross it out because then it will be hard if I need to reference it later to see what it was. We can just do a dot above or below. 132 is the lowest entry. I believe that's followed by 147, which is then followed by 159, then 174, then 181, and finally 253. As we did before, let's find the median by just taking values from the left and right and slowly working ourselves towards the middle. We can do this because the list is now in order. And as we do this, we see we're left with 2 items in the middle. That's because there are 6 items in all. That's an even number of items, so there are 2 in the middle. So the way we find the median in this case is you add the 2 items together and then divide them by 2. This is finding the average of the 2 entries. So that value will be 166.5. That is the median value in our list. A third measure of central tendency is the mode. The mode measures which value occurs the most often. And one thing to keep in mind in terms of mode is that there could be no mode if all the values occur only one time. In that case, there's no value that occurs the most often. There could be a single mode if there is one data entry that occurs the most amount of times. Or There could be 2, 3, 4, 5 modes, etc. if there are multiple data entries that all occur the most times together. So in this next example, we have 10 students who earned the following scores on a history exam. We are asked to determine the mode score. So what we would do here is we would ask ourselves, do any of the data items repeat themselves? If so, do any of the items repeat themselves the most? Take a moment to glance through this list. We see that 74 repeats itself 3 times. And the remaining items are 81, 39, 82, 80, 100, 92, 85. None of the remaining entries repeat themselves. So in this case, our mode is 74 because it's the most commonly occurring data entry. So there is one mode in this example. In our next example, we're asked to find the mode for these data values. Look through the list and ask yourself, do any of the entries repeat themselves the most? As we look at this list, no entry is repeated. 10, 4, 5, 822, 100. None of those appear more than one time. So since there are no repeated data items, this implies that this data set has no mode. Now in this next example, we have our list of data given to us in the form of a stem and leaf plot. Earlier we talked about how we would read a stem and leaf plot. Let's review that briefly before we get to the question of what is the mean, median, and mode for this example. As a quick quiz, can you identify what value is indicated by this entry in the stem and leaf plot? As it is in the row that starts with a 7 and the entry itself is 5, that represents the number 75. Okay, next review question, is the digit 47 included in the stem and leaf plot? And if so, can you visually focus on where that entry would occur? So for the digit 47, it starts with a 4, so we would look in the row that starts with a 4. And we see there is a digit 7 there, so that is our 47. 47 is included in the stem and leaf plot. Next question, is 50 included in the stem and leaf plot? Well, as 50 starts with a 5, we would look at this row, but then we see there are no entries in this row. So since there's no entries in this row, this is telling us there are no data items that start with a 5. So 50 is not in this stem and leaf plot. If it was to be part of the stem and leaf plot, now here I am changing it just to show everybody, you would have to have had a 0 entry here to show that there's a 5, 0 as part of the data items. Now, of course, that was not there, which is why our answer to this question is no. So now that we've briefly reviewed how to read the stem and leaf plot, let's go back and answer our questions about central tendency. Let's first look for the mode. The mode is usually one of the easier of the central tendencies to spot. Look through our list of data entries in the stem and leaf plot and ask yourself, do we have any repetitions? And if multiple, who occurs the most frequently? So looking at the stem and leaf plot, we see in the row for the 6 number starting with a 6, we have 2 8s, which means we have 68 and 68 repeated in the data set. Similarly, in the row that indicates digits starting with a 7, we have 2 2s, so that means we have the 72 and 72. Now looking, I don't believe I see any other repeated digits in the stem and leaf plot. So we see 2 numbers that are repeated twice, so they tie for most repetitions. So the mode, there's going to be 2 modes, and they are 68 and 72. So this is an example with multiple modes because they tie for most frequently occurring. Next, let's calculate the median. Now from this stem and leaf plot, can you see that everything is already listed in order? I have the lowest entry, 44, followed by the next lowest entry, 46, followed by the next lowest of 47, and then the next of 49. Similarly, I have the highest entry of 106 here. So the nice thing about the stem and leaf plot is it's already in order. So in order to find the median, I can carefully work with the stem and leaf plot to figure out exactly what would be the middle value. One option is you could write out exactly what digits are included and then find the middle, but that would take some time. So instead, let's work directly with the diagram. I'm going to take off the lowest entry and the highest entry. Next, I look at the next highest entry remaining, that would be 88. I cancel it along with the now lowest entry of 46. Continue this process until we're left with something in the middle. So as I restart this next row, I'm trying to cancel the remaining highest, so I cancel the 76. I pair that with canceling with the 63, now the 75, now the 64, 72, 66, 72 again, 68, and we see we're left with one item in the middle, which is our 68. Now the the median is still 68, but I just realized I got a little off as I was talking and trying to show canceling each term. So let me repeat that again and we'll get it correct this time. Cancel the highest, cancel the lowest. Cancel the next highest, cancel the next lowest. Continue, not getting out of order. And now we see the remaining term is 68, but now we have the correct 68. Now that was one option to find the median, working with the stem and leaf display. If you don't mind taking a bit more time, then you can list out exactly the data elements described by the stem and leaf plot, and then finding the median might be a little bit easier because you're not working within the diagram, you're just clearly getting to the middle. Either way, we'd get to 68. Next, to find the mean, you could always take the time to translate the stem and leaf into the list of data entries. Then we'll add all these together and we'll divide by how many entries there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we'll add up the entire number of entries divided by 16. And we can see how you would do this if you had already listed out the values. But let's say you had not done this yet. How would we do this directly from the stem and leaf display? Directly from the stem and leaf display, you would add all the values together. So starting from the lowest on, I see there's a 44 plus a 47 plus 49 plus 63 plus a 64, which we already added, now plus a 66, plus a 68, plus another 68, now plus a 72, then plus another 72, then plus a 75, plus a 76, plus 81, plus 84, plus 88, and then finally plus 106. If we've added that correctly in our calculator, we will get 1,169. We will then divide that by the number of entries. We already counted and there's 16 entries, so we'll divide that by 16. Now I apologize for this error. I should have caught it sooner. I just recounted. The number of entries is not 16. You might have already caught this when you counted on your own. Let's recount it together. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 entries. So I need to correct this because, of course, I have to divide by the correct number of entries. There are 17 entries that we're dividing the total sum into. So now let's correctly type this into our calculator. And we get the correct answer of, when we round to about 2 decimal places, 68.76 as the mean. So in calculating the mean, I would encourage you to double check in your calculator that you added all the numbers together correctly. Do that calculation once or twice. That's how we got the 1,169. And then double check that you counted how many entries are there in the list. Make sure that's correct. Once you know those are correct, you can divide them and get the mean.